We'll now look at the mean. But before we can actually define the mean, we have to define a statistic and a parameter. A statistic is any kind of characteristic or measurement that we obtain from a sample. This can be something that we actually measure from a sample or some kind of calculation we perform on a sample. A parameter, on the other hand, is some kind of characteristic or measurement that we obtain from a population. So the main difference is a parameter comes from a population, a statistic comes from a sample. Now that we've defined those, we can actually define the mean. The mean is defined as the sum of the values divided by the total number of values. And this right here is the formula. This sigma right here means sum, so it means add up all of your data values, and n is the number of data values that we have. The sample mean, so our sample statistic mean, is denoted by an x bar. And the population is denoted by this mu. Even though we use different things to represent the sample mean and the population mean, they are both computed the exact same way. Here is our first example. Here we looked at a classroom of students and asked them their age. So we have our list of data values. To find the mean, the first step is to add all of these numbers up. 18 plus 19 plus 19 plus 24 plus 21 plus 20 plus 18 plus 18 plus 20 plus 22. When we add these all up, we get 199. After that, we need to divide by the number of students we have. And if you count these up, there are 10 data values. Therefore, my mean is 19.9. In general, whenever we are finding the mean and calculating these statistics, we round to one more decimal place than the numbers have. Here, our numbers don't have any decimal place, so in our mean calculations, we leave one decimal. We'll now talk about finding the mean of a grouped set of data. This is a set of data that is in a frequency distribution, and we want to find the mean. So the idea is the first step is to find the midpoints. So we have our data set. We can add up our class limits and divide by 2 and get your midpoint. The second step is to multiply our frequency, which we're going to denote by f, by the midpoint, which I denoted x sub m for midpoint. The next step, sum these values. We're going to add these values up. And then after that, we just need to divide by the total number of values. Similarly to when we just had a mean. So we'll say by n for the total number of values. So this time the formula is the summation of f times x sub m over n. And we'll do an example to display this. Here's our frequency distribution. We have our classes and our frequency. And the easiest way to do this is to add a couple of extra columns. One for the midpoint, and then one for multiplying my frequency and my midpoint. The midpoint comes by adding your class limits. So for instance, 54 plus 59, and then dividing by 2 to get 56.5. For the second one, 60 plus 65, and then divide by 2 to get 62.5. We can try to do the rest of them. Similarly, we would get 68.5. And then for the last one, 74.5. The next step would be to multiply these numbers by your frequency. We have 56.5 times the frequency of 3, which is 169.5. 62.5 times my frequency of 6, which gives me 375. 5 times 68.5, which is 342.5. And then the last one, 2 times 74.5, which gives me 149. The next step would be to add up these numbers that we just got. 169.5 plus 375 plus 342.5 plus 149, which gives us 1036. And then the final step is to divide by the total number of data points we had, which is the same thing as summing the frequency column. 3 plus 6 plus 5 plus 2 tells me I have 16 data points. So we're going to divide 1036 by 16, and we get 64.75. Like I said, we tend to round these to one more decimal place than our data. Since our data didn't have any decimal places, we want to only round to 1 here. So we'll write this as 64.8. The last type of mean we'll look at is called a weighted mean. So this is whenever we don't consider everything to be of equal value. Maybe some things are more important than other data points, and we want to give them a higher weight. The first step in this is to multiply a variable by its weight. And this depends on whatever the weight is, and we want to do this for all of the data points. We're then going to add up all of these values that we just found. In the last step, rather than dividing by the total number of data values we have, we divide by the sum of the weights. This time my formula is the summation of my data value times its weight, so Wx, over the sum of the weights. This one looks a little different. However, we do actually use this a lot. In particular, it's used during calculating GPA, and also many courses use a weighted mean. When I say your homework is worth 25% and your tests are worth 15%, that is a weighted mean. Let's do an example of a grade calculation. Here I have my set of categories, the grades, and their percent. So for example, our homework, we had an 87 average, and that is worth 25%. So I'll take 87 times 0.25. The next one is my class activities, which are worth 15%. I then have my first exam that's worth 10%. My second exam that's worth 10%. My third exam that's worth 10%. My final exam is worth 15%. And then I had a project that was worth 15%. After we multiply these and add them up, we should divide by the sum of the weights. However, you'll notice if you add these weights up, you get 100%, so we would be dividing by 1. And if you multiply all of these out and then add them up, you get that your average is an 84.3. And this shouldn't be super surprising. You have a couple of A's in there and a couple of C's, but a majority of things are B's. Therefore, it does make sense to have a B average.